Good afternoon. My name is Faisal Whelpley. I have login information if anybody's interested in logging in and checking this out. What I'm about to demonstrate is basically a learning management system that we built with the concept of online Mathematica. So the platform that we built was prior to Wolfram's Mathematica Online being released. So what you're about to see is our own custom implementation of it. But it does pretty much everything that you expect Mathematica to do. It is Mathematica on the web. And I don't want to spend too much time on the technology itself, short of showing you that some of the implementation details, not details, some of the differences from Mathematica that you probably cannot tell. So this is a styled Mathematica notebook. It will do evaluations just like Mathematica would. And you see the output is typeset. You can click on the output. It converts to the linear syntax input form, which allows us to do things like typeset input cells, or even using typeset in text cells. We do this by the Control-M keyboard shortcut. And when you click out of that box that gets generated, it will typeset that into a 2D expression. So you can click it back inside and change your underlying input and click back outside to make it retypeset. So each typeset is pinging the server, and this is evaluatable, so I can evaluate it again. So now the second line should be a number and not a function. We handle plots, just like you expect Mathematica to do. These are all Mathematica generated output. The Mathematica is running on our server, and every call from evaluation is getting sent back to the web browser. I'm running in Firefox, by the way. If you're going to be logging in, checking it out, I recommend using Firefox or Chrome and nothing else. So what we built is the learning management system around this technology. This is how the instructor interface looks. There's the content for all the courses that we support, mostly undergraduate, college undergraduate level. I'll talk a little bit more about the courseware right now, pretty soon. But these are some of the sample student responses that we see, the way the courseware is presented. It's a completely contained curriculum. There's no additional support to this, but students will be reading the text inside this platform. This is an example question where I believe this is the Monte Carlo simulation. So it's the students asked to do the Monte Carlo estimation here, so they have the code available to them in the presented material that they can later copy. I believe the presented material talks about estimating the unit circle and how the Monte Carlo estimation comes really close to pi. But now they have to copy that code, edit it to fit this problem where they're trying to estimate the area for the bell curve to figure out this percentage. So everything in green, shaded in green, is done automatically within this learning management system. So the student John Doe here typed this text in, typed this code in, and it's clearly highlighted for visual effects. We've also added a canvas drawing, so we can ask questions like this, draw a plot of something, and by double-clicking on any graphics, 2D graphics, you can add to the plot. So just like, just a sketching program, really. And here's a sample question that we have asked student, is in the courseware, explain how the distance formulas works. So the student actually had to do some sketches, throw in some labels, and write text on explaining. The idea behind the system is there's no machine graded. When a student does this is the student interface. When a student logs in, on the left side here, they see their syllabus. Like I said, it's a completely contained course. So basics and tutorials is where they get presented the materials for the course. They read through, evaluate any given code, much like the Wolfram programming lab idea that was demonstrated during the keynote. Working code is already given. Students have to just evaluate, and that's the interaction that they get from the program. When they go to actually try an assignment in the program, then they get to insert their own answer. So this answer gets handed in to the grader. A human grader receives, that's the hand-in button, receives the submission from the student, which shows up in a queue for them. So this is an example grading queue. Every student submission that I am mentoring, I am working with, will show up in this queue. And I have all sorts of filters that is available for me, so I can drill down to a particular submission or a particular student or a particular course. And clicking on this brings up that student submission, which I can then read. Now you see why the highlight comes in handy. I can detect the student's responses immediately and then write my own responses in there. Again, it gets highlighted as mentors or instructors' feedback, and I can send this back to the student. The system is also set up to send out email notification. So every time this interaction happens, students have control over, students, instructors, mentors have control over what kind of email notification they get whenever something exciting happens or not exciting happens in the platform. So this encourages something really interesting, a formative assessment. This is a student that I was directly interacting with that just did not get what the question was asking for the first time around, so he just wrote a few things down. And then I'm creating a conversation, creating a dialogue with the student. I'm asking him leading questions. I'm telling him, why don't you maybe rephrase the question this way? And when he's, again, attempting to follow the instructions, still cannot, I'm still leading him, never dropping, never shying away from that interaction with my students. And this probably happens like 1% of the time. Usually they get it after like the second time. So formative assessment basically allows students to retry a problem instead of just getting marked right or wrong, so they can further develop their understanding. So most of you should have access to the account, and I forgot what account you get. The Instructor Interface, which looks like this, contains all the courses that we offer, like I said, undergraduate level courses. And you can take a peek at the content based on the login that you just received. All the basics, tutorials, try it, and literacy. Now, even though this is a completely contained curriculum, you have the flexibility, you have the control over what content you actually want to present to your student. Because once you decide to teach a course, you can take that course and get a copy of it. So you can call this my course. So now this is going to create a copy in the accordion down here, if you can see, called my courses, your own version of that course. This is where you, as the instructor, get the flexibility of choosing which assignment you would like to your students to use, or determining the order in which you would like these chapters to be presented to your student. You can even introduce your own problem set. You can actually open these notebooks and edit them at will. You can toss out problems, you can add new problems, you can do pretty much everything. It is your copy of the existing pre-Kent course to edit at will. Now, once you're ready to teach, once you're ready, comfortable with the content, you can stage the course and then activate it. An active course will create a URL specific to that course, which you can then pass out to your students. Students can go to that URL and go through a sign-up process. It is free for instructors to set up this course and activate. The students, when they sign up for the course, they buy this as if they're purchasing a textbook. That's the business model for this platform. So because it's a self-contained course, there's nothing else to purchase. They don't need an additional text. They don't need to subscribe to any videos or any other thing. This is everything contained within this one platform. And we've been actively using this to teach, especially at University of Illinois. They run an online math program called NetMath. It's being run in a self-paced rolling enrollment format, so the students are not even on-site in the classroom. They're all over the world doing everything on their own time. They get something like 16 weeks to do the course. The platform-wise, the evaluation capabilities, the hand-in capabilities, you get 6 months. It's software as a service. When they buy it, they get all the course content, but they also get the ability to evaluate and hand in for up to 6 months. So you can run a course that is up to 6 months in length within this platform. So we don't do any videos, we don't do any lectures. That was not necessarily by design. That's just how it was grown. This program is based on ideas that was generated in University of Illinois around the same time Mathematica version 1 was created by professors getting together and trying to use Mathematica as a piece of technology in the classroom. So what they started doing was to teach lecture session, and then they would create these Mathematica notebooks, which eventually became the courseware that we are using, and then send the students to the lab to plug away at the computer. And they started noticing dramatic reduction in lecture attendance. And yet students were developing key understanding with the concept. And based on student feedback, they decided to not do lectures completely and spend all their class hours inside the computer lab. And the feedback was not exactly great because students were basically going wild at the computer, but developing some misunderstanding, developing some problems. So they sort of have already started doing this blended model of introducing the students to the material first in the classroom in front of the computer, and then at the end of the week, making a discussion section. And then that's when they found that students are coming in to these discussion sections with having seen the concepts of the materials beforehand, and then are able to engage actively in discussion with the instructor. So this is what's developing the understanding of the material in the students. So one other point I want to touch is, so it's instructor-led. Even though instructor is not the one that's presenting the information to the students are directly accessing the material, and Mathematica makes that, allows that to happen. Even 20 years ago, obviously 20 years ago, that was the only piece of technology that was around, and that's why this courseware was started to build in Mathematica. But even now, after being a Mathematica user for 10 years, I still find the Mathematica interface, the notebook interface especially, in collaboration with the Wolfram language, is definitely by far the best tool for teaching. Because it allows students, once you provide the code, working code that explains the concept, that does the computation, now the students can go wild and take that and run it. Our students can manipulate to support an argument or a conclusion that they arrived by themselves based on the questions asked in the courseware. And I think that's a fundamental idea there, where the students are immersed in the medium, in the platform that they are working in. They don't have to switch between digital media to paper or even listening to a lecture to a different computation platform. Everything is inside one platform. Even the learning management system of handing in work and receiving feedback. The student can even see directly what the grades are. There should, if you assign due dates, there will even be due date notifications if and when an assignment is about to be due. So everything is, the student gets not only immersed in this platform, but they're actively immersed because they actually have to produce. They have to write full sentences explaining an answer. They're not just providing an answer. If a student submits an assignment that I'm grading and I see they have provided an answer to a computation, I would send that back to the students, asking them to explain how they arrived at this computation. And because of the built-in formative assessment system, I can do that. And I'm basically, essentially coaxing out of them the words describing their thought process. And that's a key element in the system. Also, because they're essentially working in Mathematica notebooks directly, there's nothing preventing them from making mistakes, which is another key piece of, a key element to learning. When they make mistakes and figure out something or break something, that again can be used as a discussion to further deepen their understanding of the subject material. Does everybody have, if you try to access the website and you have problem, you can always reach me at faisal@makingmath.com, or there's an email on our front website in case you need to reach us. Let's see, did I skip anything else?